Good afternoon, everyone. So, welcome to the class of relations and functions. Okay. So here, yesterday we have solved the concepts of relations and functions, and also we have gone through the exercise 2.2. So I think all of you have understood the concept of relations, and also you have understood all the problems of the exercise which we have solved. Okay. So now it is the time to go for the next concept, that is functions. Okay. So here you can see that we have gone through Cartesian products and some of the important points on Cartesian products as well as problems on the Cartesian products. And next we have gone through the relations and also the definition of relation, and we have learned the concept of relation. And now we are going towards, we have solved all these problems, and now we are going towards function. Okay. So first here you have to understand what is the function. Clear? See, it starts with your sets. It starts with your sets. Clear? That is, first you must know what is set. All of you know that set is a collection of well-defined object. Okay. So first it starts with two non-empty sets. Let us take A and B. These two sets are non-empty. That means at least one element must be present in these two sets. Okay. So taking these two sets, we define Cartesian product. We define Cartesian product. Okay. We define Cartesian product, that is A cross B. Okay, we define the Cartesian product A cross B. Next, from this Cartesian product, we define relation. We define relation, or you can also tell relations, that is subset of Cartesian product. Subset of Cartesian product. Okay. So now from these relations we go for functions. We go for functions. Okay. So see, now here you must understand a function is a relation which is defined from set A to set B. See, function is a relation which is defined from set A to set B, where both set A and set B are non-empty. Are you getting my point? So that's why first we teach sets. After the sets we teach Cartesian product. After Cartesian product we teach relations. After relation we go for functions. Okay. So function means it is a relation between two non-empty sets such that there is a condition. That every element of A must have one and only one image. Every element of A must have one and only one image in the set B. Then we say that is function. Okay. That means you can understand that function is a relation. Function is a relation from non-empty set, A to non-empty set B. Okay. In which every element of A have one and only one image. One and only one image in B. One and only one image in B. Okay. So this is called function. Okay. So see here, this relation has got types, so that you learn in 12th standard. Okay, these functions are defined as types of functions, that also you learn in 12th standard. Are you getting my point? The same chapter you continue in 12th standard, where now you have just learned what is relation and you have solved some problems on relation. In 12th class, what you are going to learn? Types of relations. Here, types of functions. You are going to learn types of functions. Are you getting my point? So that's why what I say, if you are very good with the concept of relation, if you are very good with the concept of function, then you can understand types of function. If you are very good with the relation, then you can understand types of relation that we learn in 12th class. So that's why I think all of you know the logics of relations. I think all of you know logics of Cartesian product. And now we are going for the logics of functions. Okay. So function is a relation from non-empty set A to non-empty set B, in which every element of A have one and only one image in B. That means, you see here, I take this as set A and I take this as set B. So let us consider I have some 1, 2, 3, 4 elements. Here I have A, B, C and D. So now let us consider this is relation. Now let us consider this is in a relation from A to B. That is, R is in a relation from A to B such that 1 maps to A, 2 maps to B, 3 maps to C, 4 maps to D. That means what you are going to write? 1 comma A, 2 comma B, 3 comma C and last one is 4 comma D. This is the relation. Let us take it as R1. Okay. Now let us take R2. Again, let us take set A and let us take set B. And let us take this is R2 from set A to set B. 1, 2, 3, 4. Here A, B, C, D. 1 maps to A, 2 maps to B, 3 maps to B, 4 maps to C and again one more element 3 maps to D. Okay. So these are the order pairs. So now see, R2 is set of 1 comma A, that is 1 maps to A, 2 maps to B, 3 maps to B as well as 3 maps to D. Now 4 maps to C. So we say it as mapping, because in functions these are called as mapping. In function these are called as mapping. In relation these are called as arrow diagram. Please understand. Same terms, in relation they are called as arrow diagrams. In function they are called as mappings. There is a lot of difference. Mappings means there has to be function. Arrow diagram means there has to be relation. Okay. Arrow diagram may become mapping, but mapping is already an arrow diagram. Okay. No problem. So now let us see. Here you just see 1 maps with only one element, 2 maps with only one element, 3 maps with only one element, 4 maps with only one element. See here, 1 maps with one element, 2 maps with one element, 3 maps with 2 elements, 4 maps with one element. So there is one element 3 which has 2 images, okay. So now here what our relation function tells, the image from set A to set B must be one and only one image. The image from set A to set B must be one and only one. But here 3 has 2 images. Here 3 has 2 images. So that's why second one is not function. second one is not function, but the first one is function. Clear? So this is what the logic behind functions. So I think all of you can understand this. No problem. It is a very simple concept. Okay. So every element from set A to set B must have one and only one image. That is called function. So quickly tell me, all of you, have you understood this concept? So once you understand the concept, reading the definition will be very simple. Don't worry. Once you understand all these concepts, now we can go for the definition and we can read it so that you can understand that what is given in the definition. Okay. So now I will go for the definition of function. Say this. So I will remove all these terms so that clearly you can see what is function. So now you just see. You read this definition so that clearly you can understand. Now you read this. A relation F from a set A to set B is said to be function if every element of A has one and only one image in set B. So see, once you understand the definition, how nicely or how smoothly you can understand that particular definition, what is written in this, okay. So from this 1.5 line you can write one complete page. Previously I have written one complete page, because if you understand that one complete page, that particular one complete page will give you the meaning of this particular definition. Clear? So from this, I think you have understood the definition of function. A function is a relation from set A to set B where every element of A is having one and only one image in B. Sometimes we also call it as unique image in B. Okay. So very good. So now you just see the next line. That is, if F is a function. See, if F is a function from A to B, order pair A comma B belongs to F, then F of A is equal to B. Where B is called the image of A. Under F, and A is called the pre-image of B under F. Okay. So you just understand this. Let us draw one diagram and let us understand it. See here, I have one function. Let us take, this is a function F from A to B. I will take here A, B, C, D. I will take here 1, 2, 3, 4. A maps to 1, B maps to 2, C maps to 3, 4 maps to D. So here this is function. So F of A goes to what? 1. Okay. F of B goes to what? 2. Next, F of C goes to what? 3. Next, F of D goes to what? 4. So here you can understand 1 is a image. 1 is an image of A. 1 is an image of A. 2 is an image of B. 2 is an image of B. 3 is an image of C. 3 is an image of C. 4 is an image of D. Have you understood this? Okay. On the same way, A here, 1 is an image of A, 2 is an image of B, 3 is an image of C, 4 is an image of D. Are you clear? So now you can see here, you can also call it as A is pre-image of 1, B is pre-image of 2, C is pre-image of 3, D is pre-image of 4. You can also call it as A is pre-image. A is pre-image of 1. See this here, 1 is an image of A. A is pre-image of 1. B is pre-image. B is pre-image of 2. C is pre-image of 3. And D is called pre-image of 4. Okay. So this is what we call, if we write f of A as 1, 1 is image of A is pre-image of 1. Are you getting my point? So here 1 is image and A is pre-image. A is pre-image. Have you understood this? Pre-image means you just see here, if you write f of A equal to 1, f of A equal to 1, 1 is image, A is pre-image, okay. So A goes to 1, that's why 1 is called image of A and A is called pre-image of 1, okay. So if you write A comma 1 like this, 1 is image, A is pre-image. 1 is image, A is pre-image. Okay, very good. So now you have understood a very, very important thing. So before go to the next concept, you just see some more concepts to clear this particular thing. So I will write some diagrams here. So you have to tell which is function and which is not function. So this is the first one. 1, 2, 3, 4, 5. A, B, C, D, E. 1 goes to A, 2 goes to A, 3 goes to B, 4 goes to B, 5 goes to C. Second one. Again same 1, 2, 3, 4. A, B, C, D. 1 goes to A, 2 goes to B, 3 goes to C, 4 goes to D. Next, third one. 1, 2, 3, 4. A, B, C, D. 1 goes to A, 2 goes to B, 3 goes to C, and 4 goes to C. Fourth one. 1, 2, 3, 4. A, B, C. 1 maps to A, 2 maps to B, 3 maps to C. So now tell me, here there are 4 options, or you can take 4 examples. You can take it as 4 examples. In this, which one is function and which one is not function? Quickly you have to tell me. Quickly you have to tell me. Which one is not function? You tell me that. That's enough. In this 4, which one is not function? In this 4, which one is not function? You tell only that much, so that I can understand how much logics you have understood. Okay. So I want only which one is not function. You tell which one is not function. Very good, very good. So most of you are giving a right answer. Fourth one is not function. Fourth one is not function. Why? Because you just say there is one element 4 there is one element 4 which is not having any images. Not having any images. Not having any images. Clear? So therefore you can just go through the definition and once again you see what the definition tells. A relation F from set A to set B is said to be function if see this is important, every element of set A, that means every element of set A must have image. Every element of A must have image, but here you can see 4 is not having any image. Okay, so that's why 4 is not function. Okay, and how that function must be? That function must be in such a way that it must have one and only one image. It must have one and only one image. Okay, see here, only one image, only one image, only one image, only one image, only one image. So therefore this is function. First one is function. First one is function. Next, one image, one image, one image, one image. Function. One image, one image, one image, one image. Function. Okay. Suppose if I write like this, 1, 2, 3, 4, A, B, C, D, 2 maps to B, 2 maps to C, 1 maps to A, 3 maps to D, 4 maps to C. Now this is also not function. This is also not function. Why? See here, 2 has 2 images. 2 has 2 images. So that's why 5 is also not function. That's why 5 is also not function. Okay. So that means now it is very much clear to everyone. Now it is very much clear to everyone. Okay. But some students are in confusion with first example as well as third example. Why they are in confused? Because see this D and see this A. See what the definition tells. Every element of set A must have image, but it doesn't tells that the set B must have, all the elements of B must have an pre-images. It doesn't tells like that, or all the elements of B must be an image of some element, like that it doesn't tells. So set B is not considerable here. Whenever you are defining a function, you should start with set A. Set A is important. They are not concentrating on B more. They are not concentrating on B more. They are concentrating on A set very much. They are concentrating on A set very much. Okay. So that's why here this is going to be function and 3 is also going to be function. Okay. So I can give very beautiful examples for this because this is an online class. So we can't express those type of examples for this. So with this statement, so many of you have understood what are those examples. Okay. So I can understand that so many of you have understood what are those examples. Clear? No problem. Like this also we can give examples in mathematics without writing, without explaining, without telling. You can understand what are those examples. Okay. No problem. So now I think all of you have understood what is function. To be the function, how the relation must be from set A to set B, and how the mapping is going to be done. Those all things are explained here. So that's why I can understand those things, no problem. So I think all of you have understood this. So one example, see here. A person can send message to B person. A person can send so many messages to B person, but there is no need that B has to reply for that. There is no need that B has to reply for that. Okay. So that's why here there may be some messages or some elements which are not replied. But here all the elements are giving a messages. But there is what about the reverse case? In this person B may not reply for this messages. So this you can take one small example. Okay, that which not make more harm. So we can give more beautiful examples also, but that I am not going to tell now. Let us check it later. Okay. So now this is over. Now coming to one more example to just go through it because it is very important. I will write one function f from set A to set B. So this is function f from set A to set B. I will take A, B, C, D, E, F. 1, 2, 3, 4, 5. Okay. So you can just go A maps to 1, B maps to 2, C maps to 3, 4 maps, D maps to 4, E maps to 5. I will write 6, 7. F maps to 6. And you can write 8, 9 also. No problem. Now, set A is called domain of F. Set A is called domain of F. Please understand this. Set A is called domain of F. Okay. Next, set B is called codomain. Set B is called codomain of F. Set B is called codomain of F. And you just see range. Range is collection of images. Range is collection of images. That is 1, 2, 3, 4, 5, 6. So this is range. Set of 1, 2, 3, 4, 5, 6. This is range. And set A, that is A, B, C, D, E, F. This is called domain. And codomain is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is codomain and range is 1, 2, 3, 4, 5, 6. Okay. So range is collection of images. Are you getting my point? And domain is set A. Codomain is set B. See here. A relation is defined from set A to set B. A relation is defined from set A to set B. This set A to set B. Set A is called domain. And set B is called codomain. Set B is called codomain. Okay. This is when it is function. In relation already we have discussed. Okay. Don't mix the concepts. Don't mix the concepts. In relation already we have studied about domain and range. But in function, if function is defined from set A to set B, A is called domain, B is called codomain, and collections are called range. Very, very important concept that you must remember. Don't mix the domain, range, meaning of relations and functions. In function it is defined in different manner, and in relations it is defined in different manner. So in relation, what is domain? You already studied. What is range? You already studied. But in functions, set A is called domain, set B is called codomain, and collection of the images are called range. So I think everyone can understand this. Okay. So now quickly I will go for one more diagram so that you can understand it. See how we write domain, codomain, and range. This is domain, that is set A. This is codomain, that is set B. So it is a function f from A to B. Now this is called range. And set B is codomain. set B is codomain. Okay, so here range is going to be subset of codomain. Please understand this. Range is going to be subset of codomain. Range is going to be subset of codomain. Range is subset of codomain. Range is subset of codomain. Okay, so that you can understand, no problem. Clear? So with this you can understand what is function, to be in a function, how the relation has to be, and what is codomain, what is domain, what is range, what is image, what is pre-image. These all things we have studied. Okay, so all of you have to make notes of this, writing the definition of domain, writing the definition of codomain, writing the definition of range, and draw the mappings which I have solved examples. I have given the examples, you take those only examples and you write them. You write everything in your notes which I have explained in this class. Clear? So you can watch the video while writing the notes. So you have to write that notes very much neatly, because these all are the basics of your 12th standard, that is relations and functions chapter. So there you must not get any confusion. So that's why please make that notes very much neatly. Very much neatly. Okay. No problem. Now let us go for the next concept. See, sum of functions and their graphs. Sum of functions and their graphs. So before going to this, again I will explain some geometrical meaning of the function. Geometrical meaning of the function. You just see, you are going to have y-axis, you are going to have y-axis as well as x-axis. See this, let us take this is y-axis and let us take this is your x-axis. Okay, so now from this you can understand, if I draw any curve on this, okay, you take like this, no problem. This is the curve. Clear? So on the graph you are going to have x-axis, on the graph you are going to have y-axis. So this is x-axis, this is y-axis, and what is this line? Can anyone tell me quickly? The line which I have drawn here is what? Can anyone quickly tell me? So this is your f of x. This is your f of x. That means here the function is from x to y. The function is from f of x to y, written as f of x equal to y, where for every x belongs to capital X. For every x belongs to capital X. So this you have to understand very much neatly. See, here f is a function from capital X to capital Y, and it is defined as f of x equal to y. Small x is belonging to capital X and your small y belongs to capital Y. Small y belongs to capital Y. Okay. So now by using the elements, by using elements of x, we get the values corresponding in y. That means the corresponding elements, by taking on the x-axis, you are going to get corresponding elements on the y-axis. Clear? Say this here like this. Okay, like this you can get here also, like this you can get corresponding to x, you will have corresponding y value. Here also you can see corresponding to x, you have corresponding y value, corresponding to x, you have corresponding y value. Okay, So by combining these all points, now I will draw this particular curve f of x. Clear? So that means x is domain, y is codomain. Clearly, x axis is domain, y axis is codomain. And f of x is function. F of x is function defined from f of x equal to y. That means, you see here, now if I write f is a function from x to y, you have to understand x is x-axis, y is y-axis, x is domain, y is codomain, and this function f of x equal to y will be our function, which can be drawn on the graph. That means a function represents the graph. Please understand, every function represents the graph. So we have to understand what is the graph of that particular function. So that is very, very important. Are you getting my logic here? Every function, the function what we define, for that there will be domain, for that there will be codomain. Using that domain and codomain, we can draw the graph on the respect to x-axis as well as y-axis. So I think you have understood how we are going to draw the function. Okay, draw the function means we are going to draw the graph of that particular function. Clear? So by taking the values of x-axis, we put in this and we get y value and we take y value. Clear? So for example, you see, if I take f of x equal to x square, if I take x value as 1, that will be f of 1. 1 square is 1. If I take f of 2, 2 square will be 4. So 1 will be on x-axis and this one will be on y-axis. And here 2 will be on x-axis, 4 will be on y-axis. That means 4 is the value of range. 2 is the value of domain. Okay. So see here, these all things no one asks in your exams. But if you understand these things, then only you can solve the problems which are in exam. Very, very important thing. Please understand here, these all things no one asks in exam. But unless and until you don't understand these things, you can't answer the problems or the concepts which are going to be asked in exams. That is what the beauty of understanding the concepts. So that's why I explain in detail. That's why I always explain in detail. Once you understand them, then you can solve any type of problems or you can solve any type of concepts. So that's why understanding the concept is very, very important. So you take care of all these concepts. So from this, now you can go for solving the functions as well as their graphs. Okay. So my dear students, please listen. Every function and the graph of this particular 11th class has to be remembered. Nature of the graph as well as definition of the function, as well as domain, range of the function. These all things you have to remember. If there is a function, you must know what is domain, you must know what is codomain, you must know what is range, you must know what is graph. That is the importance of this particular concept, that is some functions and their graphs. So here first you can see identity function. First you can see here identity function. Okay. So you go through this. What is identity function? Then we can understand it. No problem. So listen here. That is, let R be the set of real numbers. Let R be the set of real numbers. Define the real valued function f from R to R. That means R is real number set. Again R is real number set. Clear? Given by y equal to f of x, that is equal to x. Please say this. Please say this. Very important. Defined by y is equal to f of x, that is equal to x. For each x belongs to R. For each x belongs to R. Such function is called the identity function. Such function is called the identity function. Here the domain and range of f are real numbers. Here the domain and range are real numbers. So therefore the graph is straight line. The graph is straight line. Okay, no problem. So now you have read this definition. Now we shall understand this. What is this definition? Say this. F is defined from R to R, where R is real number set, and this R is called both domain and codomain. R is domain as well as R is codomain. Okay. So now it is defined as f of x equal to x, and also please see they have written y equal to f of x. That means this is nothing but f of x. Y is nothing but f of x. Are you getting my point? So this will be used in the second year. No problem. Now I will take it out of this. Okay. So now I will only write f of x equal to x. Clear? Okay. So that means what is your input from the domain, that will be the output in your codomain. What is meaning of this? The input which you give from the domain, the same thing will be the output from your codomain. Please understand this. The input that you give from the domain, the same will be the output in your codomain. That means if I write f of 1, 1. If I write f of 2, 2. If I write f of minus 3, minus 3. If I write f of 4, output is 4. If I write f of minus 5, output is minus 5. Okay. So the output, the inputs what you write from the domain, the same things will be the output in the codomain. If such you are getting, if you write such things, then we can tell that it is identity function. That means you just see how will be its graph. So this is the graph of identity function. You can just see here. If I take this point from the x-axis, the same point will be from y-axis. This is output. If I take this point from x-axis, the same point will be on y-axis. So this is output. Like this, you are going to have the elements. Okay. Minus 2, minus 2. Minus 4, minus 4. Minus 6, minus 6. Minus 8, minus 8. Okay. These are the points. Clear? So now all of you can understand that this is the line passing through the origin, y equal to x. We also say this as y equal to x, line passing through the origin, and please remember angle made by line with x-axis is 45 degree. These all things you must know. The angle made by line with the x-axis is 45 degree. Okay. So from this, I think you understood so many number of concepts. What is function? Well, now you have understood what is identity function. Clear? So here very important thing is you have to remember the nature of the graph. First thing, nature of the graph, very important, that is shown in the diagram. Second one, domain. Third one, range. Fourth one, angle made by the line, and at least these things all you must remember. Okay, so if you remember all these things, then you can do, or you can enter into some of your CET chapters. Okay, so that's why I tell, please understand the concepts in depth. These all things they never give in your NCERT textbooks. These things only comes from number of textbooks you read. You read some competitive books like Errorless or Cengage or Aryan publication or like that. So if you go through only the NCERT, in NCERT they are never going to write like this. Okay, so they will give more number of informations they are going to give in NCERT, but you go for competitive books and you read there. So this all knowledge comes to you. Okay, so here please you have to remember these 4 points: nature of the graph, domain, range, angle made by the graph, and the first important thing is definition. First you must know definition. Okay, this is very important. First you know the definition. With definition, these 4 remarks, you can tell it as remarks, no problem. Okay, so like this you have to study. And now let us go for the next one. That is constant function. Okay, so see what is constant function. You see here the constant function is okay. Constant function define the function f from R to R by y equal to f of x equal to c. X belongs to R. Where c is a constant. And each x belongs to R. Here domain of f is R and range is singleton set C. So let us understand this, no problem. Constant function means it is defined from real numbers to real numbers. F is defined from real numbers to real numbers. That is given by f of x equal to c, and you can also write it as y, no problem. Y equal to f of x equal to c. Okay, so here for every x belongs to R, that is domain, means if I write f of 1, c is my constant number. If I write f of 2, for that also it is c. If I write -2, for that also it is C. If I write 3, for that also output is C. If I write anything here, output will be C. That is fixed. You can write anything for the X value, but here the output C is going to be fixed. Output C is going to be fixed. Okay. So if the output is fixed, that is nothing but constant. That is nothing but constant. Okay. So for that you can see the graph. For that you can see the graph how it is going to be. You can take any value from the domain. You can take any value from the domain. See here. From the x-axis you can take any value, but it is always fixed for. It is always fixed for C. It is always fixed for C. Okay. Clear? You can take any value from x-axis, for it is always C. Clear? So that's why you can say that it is constant function, that is f of x equal to C for every x belongs to R. That is real number set. That is nothing but your domain. That is real number set. So therefore here what is your domain? Domain is real number set. What is your range? See, in the range you have only one element, that is C. So you can write it as C. Only singleton set C. Okay. So therefore here you can understand, if this C is going to be fixed, if the output is going to be fixed, then it is called the constant function. Then it is called the constant function. Clear? So here they have taken is f of x equal to 3. That means it is fixed for 3. It is fixed for 3 for any value of x. For every x belongs to R. Here f of x is equal to 3. So in generally, if f is defined from R to R, here the range is going to be what? Range is going to be singleton set 3. Range is going to be singleton set 3. Okay. So now here by looking at this, now you have understood domain, now you have understood codomain, now you have understood range, and also the nature of graph. Also the nature of graph. So what are the outputs of this? What are the outputs of this? Go to your straight line topic. There I have explained some important concept. There I have explained some important concept, that is slope of horizontal line. Slope of horizontal line, or you can also say slope of parallel line to x-axis. Can you tell me what is that? Can you tell me what is that? Slope of horizontal line, or you can say slope of parallel to line x-axis. Parallel to line x-axis. So that is slope is equal to 0. Slope is equal to 0. So that you can see from the graph, because constant function is going to have an horizontal line. Constant function is having an horizontal line. Hence from that horizontal line you can just see if this is parallel to x-axis, we all know that the x-axis is having slope as 0. So therefore the parallel lines to x-axis is going to be 0. Therefore the horizontal lines are always having the slope as 0. So therefore you can tell that the constant function is having slope as 0. This is a very good note that you have to remember. This is the very good note that you have to remember, and this we are going to use in application of derivatives also. applications of derivatives also, because in 11th class you have learned that the differentiation of constant term is 0. The differentiation of constant term is 0. Yes or no? Everyone knows that the differentiation of constant term is 0. And also you also know that dy by dx is nothing but it is slope of tangent. It is nothing but slope of tangent. So you can see here, this is the horizontal line itself, it is an a tangent. Itself it is an a tangent. Therefore, you can just understand that this tangent is having m equal to 0. And you can also see that the differentiation of constant term is also 0. So like this, if I go on explaining about the functions, it goes on, and it has very less end. Okay, it will be always like a tangent. It will be moving on like this, because it has so many number of concepts which it has been involved. So when you read number of books, these all things are going to be understand. But for now the important thing is, first one, definition. Second thing is domain. Third thing is range. Fourth thing is graph. And you also remember about slope and all, no problem. You also remember about slope and all, no problem. And now we can go for the next concept. So I think all of you have lost your patience, and most of you, I don't know how much you feel interest to study like this, but I feel very happy to make the concepts clear like this. There were 50 students at the starting of the class, but now there are only 40 students. 10 students have left the class, no problem. But I think all of you get bored if I explain like this. How many will feel interest if I go on teaching like this? Please give me yes. Because I really enjoy teaching like this. So you also tell me how many of you are going to enjoy if we teach like this. So please here understand the concepts so that we can continue in the next class. So make notes of this, everyone. Don't forget to attend the classes regularly. Thank you everyone. Be safe so we can continue tomorrow. No problem. And be safe. Okay, being safe is very important for now. So be safe. Don't go out of homes. Please be in home. And let us continue this in tomorrow's class. Okay. So thank you everyone. Take care. Bye.